Hey everyone, welcome to our next lesson. We're going to be starting a unit on circles, and we are going to start off with section 10.1, which deals with lines and segments that intersect circles. We're going to be learning a lot of vocab today. A circle is defined to be a set of all points in a plane that are equidistant from a given point called the center. Here we have a circle with center P, and we can call this circle P. We can use this notation, a circle with a little dot on the inside P, and this just is notation for circle P. A radius, our definition for that is a segment whose endpoints are the center and any point on a circle. Here is our radius. The endpoint here at the center of the circle, and it ends at a point on the circle. A chord is a segment whose endpoints are on the circle. Over here we have an example of a chord. Notice that it intersects the circle on 2 points. A diameter is a special kind of chord that contains the center of the circle. Here is a diameter. Again, the endpoints are on the circle, and it crosses through the center. We also know the diameter is made up of 2 radii. A secant is a line that intersects the circle at 2 points. So it is like a chord, but a chord has 2 endpoints, whereas a secant is a line that continues in both directions. A tangent is a line that intersects the circle in exactly 1 point called the point of tangency. This line, AB, is a tangent line of the circle. Notice that it intersects the circle here at point B. This point B is called the point of tangency. We're going to be using these vocab words to identify special lines, rays, and segments of a circle. In example 1, we're going to be given a segment or line or ray of a circle, and we will need to identify as either radius, chord, diameter, secant, or tangent of the circle. Let's start off with A1. We have a circle here with center C, and we're asked to define what the segment AC is. So AC is here, an endpoint is the center of the circle, and the other endpoint is on the circle. So this is a radius. So as you are identifying what kind of special segment this is, just take note of the definitions that we have for each of these special segments. For 2, we're asked to define what AB is. Here's AB. I noticed that the endpoints are on the circle, and it crosses through the center. So this is a diameter. For part 3, we are asked to define what ray DE is. So let's take a look. Here's DE. I noticed that it crosses the circle at 1 point B. So this is a tangent. Let's end off with AE. So AE is here. It's a line that crosses the circle in 2 points. So this is a secant. I'll let you guys try the next part, and let's move on to some more vocab. Next, we'll be looking at coplanar circles and common tangents. So in a plane, 2 circles can intersect either at 2 points, 1 point, or no points. Here's an example of 2 points of intersection, 1 point of intersection, and no points of intersection. Coplanar circles that intersect in 1 point are called tangent circles. So here is our example of tangent circles. They intersect at 1 point. And coplanar circles that have a common center are called concentric circles. Over here is an example of a concentric circle. They share the same center. This might be a word that you've seen before. A line or segment that is tangent to 2 coplanar circles is called a common tangent. Here is an example of the tangent lines for the 2 circles. A common internal tangent intersects the segments that joins the center of the 2 circles. And a common external tangent does not intersect the segments that join the centers of the 2 circles. I'll show you what I mean by internal and external tangents once we jump into example 2. In example 2, we're asked to tell how many common tangents the circles have and draw them. We're going to use blue to indicate the common external tangents, and then red to indicate the common internal tangents. I don't have a red pen on me because I don't believe in red pens, so I'm going to be using orange for my internal tangents. And recall that our definition for these tangents depends on whether they intersect the segment that joins the center of the 2 circles. So for the first example, 2A, I'm going to draw the line that connects the 2 centers. If the tangent crosses that line that I drew just now, it's going to be considered an internal tangent because it crosses the center of the 2 circles. If the tangent line does not cross that purple line, then it's going to be considered an external tangent. So I'm going to be drawing my tangents initially with pencil, and then I'm going to color code it based on whether it's internal or external. For tangent lines, you want to draw a line that intersects each of the circles at exactly 1 point. I'm going to draw the first one that I see. There's my first tangent. Notice that it crosses the two circles at exactly 1 point. Now, because it does not cross that purple line that I drew earlier, this is going to be considered an external tangent. So similarly to the one that I just drew, there's also another external tangent that crosses the two circles on their bottom sides. All right, so already we have two tangents. Now let's see if we can draw some internal tangents. So internal tangents are going to be lines that cross each of the circles at exactly 1 point, but it also has to cross this purple line that I drew initially. So I see one here, and likewise there is another crosses in the other direction. Okay, and those are internal tangents because they cross that purple line that we drew earlier. Now, if you are having trouble seeing these common tangents, one thing that you could do is you can just take your straight edge and then just maneuver it so that you find the line that crosses these circles in 2 points. So let's say how many common tangents it has. We were able to find 4 common tangents. There were 2 internal and 2 external tangents. So now let's look at B. I'm going to draw that line that connects the 2 centers of the circles again. And now we want to find the tangents for the 2 circles. All right, so I feel like there's going to be one that crosses on the bottom edge. We can see right there. It's not going to cross that purple line, so this is going to be an external tangent. There's also going to be another one that crosses the 2 circles from the top side, so let's find that one. So we're going to use our straight edge, and we're going to find that line where it crosses the 2 circles at 1 point exactly. Okay, so it looks to be about there. Okay, let's pretend I drew that a little better. So already we have 2 external tangents. And then we want to see if there's an internal tangent. Is there one on the inside? If we look over here, there's also a tangent on the inside right here. And because this line is going to cross through that purple line that we drew earlier, this is going to be considered an internal tangent. All right, so we were able to find 3 common tangents. There are 2 external tangents and 1 internal tangent. We're going to do this one more time. All right, so for C, let's draw that line that connects the 2 centers of the circle. And we're going to use our straight edge to find some external tangents. Pretty sure there's going to be one on the bottom again. Looks to be about there. There's going to be another common tangent that crosses the 2 circles from the top. And then we want to see if there is an internal tangent. So let's take our straight edge. We want to see if we can find a line that crosses both of the circles in exactly 1 point. So if I look here, this doesn't work because it crosses the 2 circles at 2 points. So we actually do not have an internal tangent. We only have 2 common tangents and they're both external. I'm gonna let you guys try D, E, and F, and that's it for our lesson today. Let me know if you have any questions, and I hope you have a wonderful day. Take care.